Whew. Just has some nice fish and with yams, carrots, potatoes, and some peach juice, and then a pear. So, uh, I don't make any scientific videos because, I mean, it's all written in the documents. But since I also don't really make any new science research because I'm always doing other things like other stuff, all my other documents. And I figured because I'm not making any more new science shit, might as well make a video explaining what I've made to date so far. So I got a couple of science folders here. Let's open them up. Got this one. I've got about, a couple of things. And the first thing I started researching, I did 3 areas. I did cancer, neural networks like paralysis and neural networks, and then these are kind of related because cancer is cells that grow uncontrollably and steal nutrients from healthy cells, and they bypass markers. They all have proteins and enzymes which are coded by DNA. So DNA and messenger RNA code proteins and enzymes, and these proteins and enzymes, some of them are markers, some of them are structural, functional, some of them are commands. And what they do is they organize what the fuck goes on in the cell, all the commands that happen in the cell, including reproduction, growth. So cancer growth is done by the proteins and the enzymes as well. They get signals to grow, they steal nutrients, their shape and form is all coded by their command center, which are the proteins and the enzymes, which were created by DNA and mRNA, messenger RNA. So, and the neural networks are also cells. They got a nucleus and they got a long tail, which is the axon, and they got coded in myelin to make it quicker signals, and they rest at like minus 50 millivolts. They get a signal, they shoot up to plus 50 millivolts, and they go back down to resting neutral. And they all shoot down a chain of command from your brain to wherever they got to go in the body or just within the brain. And when one shoots, it sends neurotransmitters to the next, across a synapse, across a gap, to the next cell. And these neurotransmitters change the voltage, which creates it to fire, or they give a command right there. It could be a chemical command. So it could be an electrical command, or it could be a chemical command. And there's like 4 different chemicals: glutamine, adenine, thymine, ketamine, methamphetamine. I don't know what the fuck they are. And they're neurotransmitters in balance, and they fire across different neural networks. So what I try to do with cancer and neural networks is bring about a more healthier approach, because right now the treatments that we've been using are chemotherapy, radiation, and surgery. So chemotherapy attacks the healthy cells as well, so that's why you get side effects. And radiation is like radiation to kill the cells, but it also attacks healthy cells as well. And surgery is surgery to remove tumors. And in the case of neural networks, we attack the neurotransmitters. So we inject neurotransmitters into psychotic diseases like schizophrenia, bipolar. We give medicines that target neurotransmitters, dopamine, THC, and medical marijuana. All these drugs, they're drugs that target neurotransmitters, which change the firing between the synapses and the different neurons. But that doesn't help repair broken neurons like a spinal injury cord, or you have ALS and motor neurons which are affected. So when your motor neurons are affected, then you can't talk, you can't move. That's like ALS. And you got neurons which are responsible for the body functions like breathing and heartbeat. So when those fail, you die. So you got a lot of diseases that happen with the neural networks that just stop working and functioning. So I tried to come up with how can we naturally help the body grow and repair neurons. One way is to do it with stem cells. I thought if you take a stem cell and you turn it into a baby neuron, it will automatically migrate to where it needs to go to repair shit. Then I thought, what if you could do alternative pathways? So skip a signal and go to the next healthy neuron. So that's an alternative pathway. It's like a circuit. Instead of 2 connections, you got multiple connections, and you can pick which connection works. Then I thought about, what about if we play with the voltage level, make it easier for our signals to fire? So if you got 50 millivolts, bump it down to 10 millivolts and see 20 millivolts, 25 millivolts, and see if it's easier for signals to get across. What if we can repair the tail, the axon? What if we can improve the sheath, the myelin sheath? The dendrites, which are the nerve endings, the dendrites, which collect and send the synapse signals. So all of these were like a holistic approach, I thought, to fixing the neural network, which is more than just using drugs to dopamine and THC to attack the neurotransmitters. And for cancer, I did the same thing. I said, instead of just using radiation, chemotherapy, and surgery, what if we could attack these fucking specific proteins and enzymes which command cancerous cells and healthy cells to grow, to eat, to take in nutrients, to replicate, to die, the life cycle, the entire function of the cell. So you could do that with DNA, target the DNA to produce certain proteins or produce less of certain proteins. Or you could target the proteins themselves, inject new proteins, take out proteins. Or what I thought of was to distract them. So you got proteins that are working, but what if you attach an enzyme, which is a catalyst to a reaction? So it speeds up a reaction and it incites a new reaction. So what if we distract a certain signal? So you got this protein is a receptor and this protein is a command. And it gets a message on the receptor and it sends it to the command and an action happens. What if we get an enzyme in here to attach to this receptor? So all the proteins are still there. We didn't change the biology, but we changed the enzymes. So now they get distracted. So instead of going to this protein, they turn it to something else. And that command to replicate or live forever and not die doesn't exist anymore because we've distracted them with enzymes. So it's enzymes and proteins. And this is the field of microbiology. And more specific for cancer, it is called targeted therapy. Targeted therapy means targeting exactly that, the certain proteins and enzymes which command for certain cancers to grow. However, for targeted therapy to work, you need to identify where the location is with gene markers, genetic markers. And not all cancers have genetic markers. So that's why when we can use targeted therapy, it is effective with low side effects because it only targets the cancer. But it needs markers and shit like that to identify. Not all cancers have that. So chemotherapy targets all cancers. And then you have immunotherapy, which is another method I thought of, just the immune system helping to regulate itself. So we added boosters to make the immune system go even stronger and stop being so cautious and go full force and attack cancerous cells. The problem is cancer gets even resistance to this, and also you develop some side effects like inflammation, fatigue from a hyperactive immune system. But what we do now is we combine therapies. So we use targeted therapy combined with immunotherapy, combined with the radiation, chemotherapy, and surgery, all to provide the best outcome. The different types of cancers that are most survivable are like breast and prostate cancer. They're caught early, and they have like an over 95% survival rate for breast and prostate cancer. The least survivable cancers are pancreatic and brain cancer. They're 10% survival rate because they're so hard to detect and so secluded in the body that it's hard to fight them, and they're hyper aggressive. So pancreatic cancer and brain cancer are 10% survival rates because they're late stage diagnosed and heavily hard to target. Cancers usually develop from old age and from things like obesity, diabetes, lung cancer, smoking, stuff like that. And age plays a factor as well. So like cancer screening doesn't start until you're 45 or 50. And then you got blood cancer, which is leukemia, liver cancer, kidney cancer, skin cancer, colorectal cancer, and lung cancer. Yeah, those are all like treatable the same way, you know. And that's about it. That's about it for cancer and neural networks. I use my theories. So my theories, I came up with immunotherapy, targeted therapy, and healing the neurotransmitters, the neural networks. I came up with all this, and then I figured out what they're actually called. So there actually exists immunotherapy and targeted therapy and that. And I used AI with all my theories. I prompted AI, Meta AI, XAI, and now I use Copilot, Microsoft AI, to find out what the fuck it thinks and what the actual technical definition is of what actually happens with this treatment and this biological process. And I documented all that. But it's basically what I explained to you right here. After that, I worked on electromagnetics. So, like microcircuitry, I wanted to do what photons, how they can interact with electrons. So you have induction, which is electricity and magnetism combined. And when electricity and magnetism combine, you can from magnets that are in motion with kinetic energy and magnetism, you can produce an electric current. And electromagnetic radiation is an electric field perpendicular to a magnetic field traveling through space, and it can travel through space, air, water, whatever, but it gets stuck with obstacles that are in its way. So I figured, what can we do with like the Earth's magnetic field, or the ionosphere, which is a negative charge in the atmosphere, or the sun's radiation? How can we use those to get these photons, which are packets of light, electromagnetic radiation, electric field, magnetic field, to interact with electrons in wires and circuits? And so I did a lot of research like that. It took me 5 years, just continuing to write like all the properties of large circuits, where you got big currents, big generators, big magnets, big electric fields. Transform that into a nanosircuit, where you have one electron, one photon, one small magnetic field, and how we can nano design on the microscopic level this electromagnetic phenomena. And it's quantum mechanics. That's what it is, quantum mechanics. And the grand conclusion that I came up with was, like, fiber optic cables are controlled light, which send communication signals. There's a message in that light. But standard cables are just electricity, not messages, just straight power. So what if you combined an electromagnetic signal with a current signal, with a power signal? So you got a power cable with a fiber optic cable. So you got a message, photons, and you got electricity, electrons. So you got electrons and photons. So you got a fiber optic cable with generating power and light signal. What's going on there? Then there was wireless electricity, which was the Earth's magnetic field and the ionosphere. And I tried to relate everything back to common knowledge, not like an engineering knowledge, like transmission line principles, antennas, receivers, capacitors, inductors, generator stations, power amplifiers, induction. So I tried to relate everything to known science and what my theories would incorporate from that. Then one new design I also thought of was magnetic capacitors. So you got a traditional capacitor, which is for electricity, but a magnetic capacitor would be for magnets. So a capacitor is a separated circuit. So you got a current, you got a cable, and you put a plate here and a plate here, and electricity jumps across the plates. It charges up the both plates, and then it jumps across the plates like a kind of battery and an ignition. And it requires AC circuit. So it's got a charge and a charge. But when you send the AC signal, alternating current, then you can get electricity to flow across the capacitor. And a magnetic capacitor, how would that work? It would be kind of like a transformer. Because a transformer is an iron core which transfers voltage and current from one side to the other side. Changes voltage and current levels around a magnetic core. So kind of a magnetic core incites a magnetic current inside of it. There's a current within the magnet. And you would need some sort of commutators to design around and flip around that current the way you wanted it to. Yeah. Then I thought of storing electricity. Right now we use big batteries. But I thought of one area that's not researched, how we can store electricity, is through chemicals. So what you can do is you can take the electrical power and use it as a catalyst to fuel a chemical reaction. And one of the chemical reactions is separating water particles into hydrogen and oxygen. So if you were to inject electricity into water, you can separate the hydrogen ions and get hydrogen fuel. Now you've got a chemical fuel, so the electrical energy is stored inside of chemical energy now. So that's how we can store electrical energy into chemical energy, and it's clean fuel. It's hydrogen fuel. It's a biofuel. The problem why it's not researched enough and developed enough is because it's not very efficient. It loses a lot of the energy. But that's a promising field where there's no way to store electrical energy right now other than batteries and supercapacitors. But we can store a shit ton, megatons of it into biofuels and chemical substances by using electricity to create a reaction to create a biofuel. And that's known as electrolysis. Then there was gravity. I thought of like string theory, just promoted gravity. String theory, you got the four fundamental forces: the strong force, the nuclear force, the weak electromagnetic, the strong proton force, electron force, intermolecular force, whatever. You got all these forces. The one we know least about is gravity. I thought of, there's Einstein's theory of gravity, and what about some like magnetic fields? Does that interact with gravity at all? I postulated that. Other than that, string theory and What else do I got? What else do I got? Oh, for environmentalism, you know how we recycle metals and plastics? I thought about what if we can recycle garbage? What if we can get all the garbage, which is stinky and all these different materials? What if we can design for all the materials that are in there? Wood, papers, organic compounds, food, metals, leather, whatever the fuck is inside garbage, and separate the stinkiness and the odors and form it into something useful, like a type of fuel or a type of material that can be used to structurally reinforce things. What if we could do something like, I thought, soaking it in acid, clearing the stink, and injecting a current into it. And it takes a lot of effort. It will take energy, but it will clean the planet. So it'll take energy, but it'll remove garbage. So it'll take energy, but it'll remove garbage. And you can even sell it. So you could purchase someone's garbage, turn it into this infrastructure, fuel, whatever the fuck it's going to be. And you got something useful, not very useful, but something better than garbage. And you can build with it and use it. So that's what I thought of for helping cure garbage problem. Other than that, that's everything. In 4 or 5 years, that's my science. So it's all in the documents, and want a Nobel Prize. Let's see here. Yep, that's about it. I used AI. I used my own creativity. I used my own scientific knowledge and background and education. I used textbooks. I used Googling. I used AI. And that's what I came up with. So yeah, let me know what you think. Let me know which area sounds promising, if you learned anything interesting or new. And as always, peace out and stay classy.